Hi, everyone. Welcome and thank you for joining us for Livewire, a stimulating night of neurotechnology. My name is Garrett Flynn, and I'm the coordinator of the Brains at Play initiative, one of many organizations, including USC Visions and Voices, Amundsen Lab of the USC Sidney Harman Academy for Polymathic Study, OpenBCI, Altiria, and Athenoi, who have supported the production of this event for you tonight. It is amazing that we have people tuning in from across the world today. As Livewire is part of the USC Visions and Voices series, we believe it's important to open our event by acknowledging the Indigenous land that our university shares. Therefore, our production team acknowledges that the University of Southern California, both the University Park campus and the Health Sciences campus, were built on the ancestral and sacred land of the Tongva Valley, Tongva Nation. We honor the Tongva and all Indigenous people, past, present, and future, and we pay respect to their continued survival and contribution to our society. We also honor the legacy of the African diaspora and recognize that this country would not exist without the free enslaved labor of Black people. We share these acknowledgements to raise awareness about histories that are too often erased or forgotten, to pay respect to the original caretakers of this land, and to recognize our place in this history. We hope that this work continues beyond our event and helps inform our individual and collective actions in the years ahead and for generations to come. This evening, we planned much for you to participate in. In addition to Discord, we invite you to post your questions and reactions in real time on Discord, an online chat site for creating communities. We've just posted a link to our Discord server in the Zoom chat, so feel free to join as soon as you can. Tonight's speakers and 9 invited experts in neuroethics will be available on Discord throughout the event to engage with you and answer any questions that you might have. We'll begin our journey into neurotechnology tonight with a series of lightning talks featuring Dong Song from the USC Center for Neural Engineering, Eran Klein from the University of Washington Center for Neurotechnology, and Judy Illes from Neuroethics Canada at the University of British Columbia. Following these talks, we'll have a dedicated public brainstorm on Discord until 5:10 Pacific time. For those of you who can't join the Discord, I'll be rotating through our attending experts and inviting them to publicly comment on high engagement posts here on Zoom. So for everyone here on Discord, make sure to show your enthusiasm by replying and reacting to others' posts. And for those of you remaining on Zoom, get ready for a lively discussion of neurotechnology and ethics. Finally, after the brainstorm has subsided, we'll wrap up the night with a concluding talk by Joe Artuso from OpenBCI on open neurotechnology. So let's begin. For tonight's first lightning talk, I'd like to introduce Dr. Dong Song and his talk, The Past, Present, and Future of Neural Prostheses. Dr. Song is a research associate professor of biomedical engineering and co-director of the USC Center for Neural Engineering. He invented the multi-input, multi-output nonlinear dynamical model of spike transformations that serves as the computational basis for hippocampal memory prostheses. Thank you for being here, Dr. Song.
Thank you for the introduction. In the next 10 minutes, I would like to give you a very brief introduction to the history, the current status, and also future perspective of neural prostheses, and share some of my thoughts on its scientific and philosophical implications. So in 1780s, Luigi Galvani, a professor at the University of Bologna, he conducted one of the most famous experiments in the history of science. He dissected a frog, exposed his sciatic nerve for his anatomic studies. Quite accidentally, he touched the nerve with a metal scalpel charged with electricity. Then something unexpected happened. The dead frog twitched his leg. An external electricity changed an animal's behavior. So this single moment marks the beginning of electrophysiology and neurostimulation, which eventually leads to neuroprosthesis. So since this very early beginning, new technology has come a long way and made many impressive progresses in the past 2 centuries, especially the past decade. Researchers start to use neurostimulation to treat different neurological disorders, including Parkinson's disease and epilepsy. So in this Medtronic system shown in the bottom right corner, electrical stimulation was delivered from this implanted device to the targeted brain region to suppress tremor or stop seizure. This device and the so-called deep brain stimulation have been very successful in treating Alzheimer's disease, Parkinson's disease, and seizure. However, it's less successful in other neurological diseases such as dementia and Alzheimer's disease. One of the fundamental reasons is that in these diseases, relevant brain regions, as shown on top, right, showed profound cell loss and neurodegeneration. The brain region is too severely damaged and make it nearly impossible for their functions to be restored. So to solve this problem, one of the more promising approaches is to use neural prosthesis to replace the damaged parts. And different from DBS, neural prosthesis seek to mimic the neural functions and reinstate the neural signal transmission. For example, in cochlear prosthesis, a little microphone was used to record the sound and transform it into neural stimulation to the cochlear nerves. By doing that, it bypassed damaged peripheral auditory system and restored auditory function, so deaf people can hear. In retinal prosthesis, a camcorder is used to transform visual input to stimulations to the retinal ganglia cells. So it bypasses damaged retinal layers and restore visual function, so blind people can see. And in the more recent motor prosthesis, the device recorded from motor areas, like the M1 region of the brain, decode the signal into intended movement. By doing that, it bypasses the damaged spinal cord and restore motor functions, so paralyzed people can move. Based on those principles, researchers at USC, including myself, developed hippocampal memory prosthesis for restoring memory functions lost in injuries or diseases such as Alzheimer's disease. So the idea is try to use a biomimetic device as shown in this cartoon to bypass the damaged brain region to reinstate the signal transmission and eventually restore cognitive function, the lost cognitive function. So in intact patients without Alzheimer's disease, information was encoded in spatial temporal pattern spikes in the downstream region of the hippocampus. And the hippocampus can transform the signal into appropriate form for the formation of long-term memory. When the hippocampus is damaged, the short-term memory is still intact, but the patient loses ability to form new long-term memories. And our goal is to try to build this device to record from the upstream region of the hippocampus and use a mathematical model to predict what the desired output signal should be, and then use microelectric stimulation to write in that signal back to the hippocampus. And by doing that, to reinstate the signal transmission and eventually restore the lost memory function. So in the heart of this prosthesis is a mathematical model describing the input-output signal transmission. This model is built based on biological principles and machine learning techniques. It can capture complex nonlinear dynamical transformation from input signals of the hippocampus to output signals. So the model was able to very accurately predict the output signal as shown on top of the figure based on the ongoing input signal in the C3 region as shown in the middle panel. You can see the similarity between the actual pattern and the predicted pattern by the model. So using the model predicted output signal, we can drive microelectrical stimulator. We were able to write in the memory information back to the hippocampus. And our results show that this memory coded based stimulation overlays on the normal hippocampal signal transmission can enhance both short-term and long-term memory functions in epilepsy patients. So these advances in new technology have drawn a lot of public attention. people start to wonder whether we can do things described in sci-fi movies. For example, download and upload people's memories, learn skills in virtual reality, as in the movie Matrix. Or even keep a full record of the memories, people's memory, so you can rewind your memories to arbitrary time point, as in the TV series Black Mirror. Startup companies like Neuralink and the Kernel are funded to develop next generation neural interface technologies that aim to enhance human intelligence, so it can be better incorporated with artificial intelligence. And in academia, the number of researchers and the publications on neural prosthesis has been exponentially growing, as shown in these PubMed search results. Note that decline in 2020 is probably due to the pandemic. The growth is expected to recover after the pandemic is over. So this is an exciting time, but here I want to emphasize that these technologies are still in very early stage. There are many remaining critical challenges that need to be overcome before neural prostheses, like those described in the movie, can become clinical viable or even a consumer product. So first, we still have very limited knowledge to basic neuroscience problems, such as how the brain works. Second, we still don't have the perfect neural interface technology that allow us to record a lot of neurons from a lot of brain regions chronically and less invasively. So we are still missing the computational model and the framework for describing the brain. And also we haven't tested the prosthesis for naturalistic behaviors during a long period of time. And lastly, which I really want to emphasize today in the context of this event, is that the ethical implications of neural prosthesis are still poorly understood. In fact, neural prosthesis was an important issue since the very beginning. So let's go back to history. As soon as Galvani discovered what he called animal electricity in his famous frog experiment, his long-term competitor, Alessandro Volta, invented batteries that can generate electrical charges as shown on the right. Not too long time after, he tested electrical stimulation on himself. He inserted 2 metal rods to his ears to electrically stimulate with his own battery. And here is what he experienced. I received a shock in the head, and some moments after I began to hear a sound, or rather noise in the ears, which I cannot well define. It was a kind of a cracking shock, as if some paste or tenacious matter had been boiling. The disagreeable sensation, which I believe might be dangerous because of the shock in the brain, prevented me from repeating this experiment. So Volta is a curious and brave researcher, but I can assure you that by today's standard, such experiment is not only dangerous, but also unethical to be performed on human subjects. There's no chance for such experiments to be approved by any IRB at any universities nowadays. So what we should do at this exponential growing era of new technology. And here's my view. I strongly believe that in neuroengineering research or in the development of a neural prosthesis, researchers shouldn't be the only player. We should include all relevant stakeholders, such as patients, their families, clinicians, healthcare providers, and the public like you, and start the conversation. I believe only with this kind of open communication, we can work together to develop not only functioning, but also ethical new technologies for the good of humanity. And this is exactly one of the main reasons we are organizing this event. And with that said, I would like to conclude my talk and take questions.
All right, thank you, Dr. Song. One question from Laura Cabrera, one of the discussion facilitators, would we be able to download and edit memories with a memory prosthesis or any neural prosthesis?
So the current prosthesis is trying to restore the function of forming new long-term memory. It doesn't store the memory. So the memory is not stored in the hippocampus, but in other brain regions. So the short answer is no. It cannot be achieved by the current hippocampal memory prosthesis. But maybe later with some more advanced technology, it can be possible.
Great. And Ashley M has a question. How can neurotechnology be made more equitable and available across socioeconomic levels? Do you have any ideas about this?
Yeah, that's a great question, right? And that's exactly the reason we try to start a conversation between researchers, engineers, clinicians, and the neuroethicists and the neurologists, right? So I think we should work together because everything is in very early stage. We need to work together to find the answer for those questions.
Great. And we'll take one more. So Siddhant Shenoy asks, how do you conduct your research if there are ethical issues about working on real human brains?
So we need to identify all the ethical issues, right? We work with other people. We work with all the stakeholders to make sure the proposed study is ethical, right? For example, the current human study we perform at USC and our collaborator at Wake Forest University was approved by IRB, right? We make sure we are not causing any damage to the additional damage to the patient's brain. And those patients are all epilepsy patients. They had to take that surgery for diagnosis purpose. And we just use this patient to perform our experiments. So everything needs to be ethical. And that's relatively easier for early human study, but in the future, I think that requires more conversation, more discussion between different stakeholders.
Definitely. All right. Thank you for your talk. And if you have any other questions for Dr. Song, you can direct them to the Discord. I'll also repost your questions from the Zoom chat in there so we could get a second shot at them during the Discord brainstorm. So next, I'd like to introduce Dr. Eran Klein and his talk, Stakeholder Perspectives on Emerging Neurotechnologies. Dr. Klein is a neurologist specializing in dementia at Oregon Health and Science University and the Portland VA Medical Center. He's also part of the Neuroethics Thrust at the NSF Center for Neurotechnology at the University of Washington. His work sits at the intersection of neurology, neuroscience, and philosophy. Thanks for being here, Eran.
Thank you for that introduction. Let me share my screen here. All right. So I'm really happy to be here. I have some disclosures. I do have received funding from the NSF and NIH. So I'm going to talk a little bit today about the importance of gathering perspectives of people who use or might use neurotechnology, mostly for medical indications. But I think it's important for me to say a little bit about my positioning here, because I think it may help give a little bit of context of kind of where I'm coming from and why I'm interested in this topic to start
Eran,
with.
you know, we can't see your screen right now. So if,
Oh, you can't. Okay.
yeah, before you go, you might want to share that.
Right.
All right, you're great.
Is that better?
Yep.
Okay. All right. So I'm a neurologist and a philosopher by training. I'm not a neuroscientist or neural engineer like Dr. Song, but I work alongside neural engineers and neuroscientists, as well as computer scientists and others in a neural engineering center at the University of Washington. And some of my colleagues who work there with me are also part of the program today. My role in this center is to help direct attention to ethical issues, both kind of current and future, in the technology being developed. As part of the center, we sort of realized a couple things early on. First, neurotechnology raises a host of really interesting and important ethical questions. But second, that kind of one critical part of getting a handle on these questions requires talking not just to scientists, clinicians, ethicists, and other sort of traditional experts, but also going out and talking to those who are sort of expert in living with conditions that neural devices are meant to help. So specifically people with different kinds of neurological or psychiatric disabilities. So as part of this center, I and people that I work with have sort of prioritized doing research that sort of foregrounds talking to people about how they do or might use various kinds of neurotechnologies, and specifically talking to them about ethical issues related to these technologies. So I think it's important to emphasize that there are indeed various kinds of neurotechnologies, and neurotechnologies span a wide range, right? So they vary by target, right? The brain, or in specifically different parts of the brain, the spine, the peripheral nervous system, muscle. They vary by location, right? Are they surgically implanted? Are they wearable? They vary by sort of permanence, right? Some electrodes, like those that Dr. Song described of deep brain stimulation, are electrodes that are supposed to be implanted for the rest of a person's life. And then others, like the ones involved in the hippocampal prosthesis, are temporary electrodes, right? That are used for a short time, days or weeks, right? They vary by whether devices have a medical indication or whether they're going to be used non-medically. And even if they're going to be used for medical conditions, they vary by the type of condition, right? So are they going to treat someone with spinal cord injury or traumatic brain injury or epilepsy? And they vary by sort of stage of development, right? So, some technologies like deep brain stimulation are very well developed, and others are just sort of at the incubator stage. So I think it's important to sort of note this heterogeneity at the start, because it helps at least me keep in view that we need to be sort of careful about talking about the ethical implications of neurotechnologies broadly, because every technology is different, and every sort of population that technology is targeted toward are different, although there can be significant and important overlap. So kind of what I want to focus on less today is sort of that diversity of neurotechnology, and more about kind of the emerging part of neurotechnology. So that is that most of the technology is sort of far from reaching its potential, right? It's still largely in early stages of development in universities and companies, and even technology that's relatively far along, like deep brain stimulation, right? It's still, which has been implanted in hundreds of thousands of people with Parkinson's disease and essential tremor and other conditions. These devices are still probably quite crude compared to what sort of the next generation of these devices is going to look like. So even here, we're much closer to the start line than we are to the finish line. So why is that important? Well, if neurotechnologies are early, and yet we can start to kind of make out the outlines of how these devices might transform human capabilities, the way they might treat diseases, assist people with disabilities, or just allow different kinds of interactions with others. The future is at least sort of partially in view. And if that's the case, then the future is malleable, right? So there may be ways to influence the development of neural devices so that they meet not just the kind of practical needs of end users, but also that doing so in a way that sort of pays attention to the ethical opportunities and costs and trade-offs of developing these kinds of technologies. So, just by analogy, I mean, just think of if we had taken more stock of privacy or the social implications of the internet three decades ago, right? The world might look somewhat different than it does today. So one group, we that should surely sort of shape neurotechnology are people who will or might one day use it. So, you know, sometimes we call these, you know, people patients or consumers, but kind of a more general term is just sort of end user, right? This is at the end of the line of developing a technology is a particular user. And this user can have very valuable things to say about technology, not just at the end when the technology is sort of handed to them or implanted in their bodies, but along the road to developing that technology in the first place, right? So there's kind of good reason to include end users in the development of neurotechnology. You know, it's a sign not just of respect, but you know, some might argue a requirement of justice, right? To include the voices of people who will eventually use technology. And even at the pragmatic level, right, getting input from end users along the way reduces the chance of a device not getting used in the end, you know, because it's cumbersome or ugly or inconvenient or whatever. So taking input from users, what's called user-centered design, is a way to make sure that neurotechnology is effectively and economically developed. But what I want to spend a few minutes talking about is the value of talking to end users, not just about preferences and functionality of devices, but about kind of ethical implications of these technologies and how they might use them. So that is, you know, neurotechnologies, and I'm going to focus mostly on sort of medically focused ones, can intersect with people's sort of deeply held moral commitments and values, you know, values such as privacy, identity, justice, agency, relationships. So what I want to do briefly is just sort of highlight a few of the things that we've heard from talking to users or potential end users about different kinds of technology. So we did this study with individuals who had deep brain stimulators implanted for Parkinson's disease, and and one of the things that we sort of heard in this study and we've heard in other studies is that, you know, having a neural device implanted can affect your sense of agency, right? So, you know, typically when we move or we think or we feel something, we assume that we're the ones doing it. But having a device implanted, you know, can sometimes raise questions for people about whether it's them or the device that's sort of in control of their agency. So one gentleman we interviewed had a DBS and gave this nice description of sort of visiting New York City and was there with his wife, and he sort of trips in the street. And you know, something that people with Parkinson's disease do, but something that we all sort of do. But because he had this device in place, this sort of extra thing comes to his mind, right? So did I trip because I was careless or distracted, or whatever, or did the device cause me to trip, right? So am I malfunctioning, or is the device malfunctioning, right? So implanted devices can raise these questions about agency that weren't there before, or at least not there maybe in the same way. So similarly, you know, we did a different study, right, where we interviewed people who had deep brain stimulators for treatment-resistant depression or obsessive compulsive disorder. They were in trials for these devices, and we asked for their experience about using these devices, and I like this quote from a kind of a middle-aged man who talked about how when he had the device, after having it for some time, he noticed that he would sort of act in ways that were sort of socially or sort of interpersonally kind of crude or insensitive, and so he sort of wondered whether or not that was just kind of him, or whether or not that was somehow being affected by the device. And so you can imagine if you had these sorts of worries, again, maybe about agency, that you might start to wonder about sort of what's the real me, right? Similarly, we talked to people who have ALS and we talked to them about the prospect of a brain-computer interface that might help them to communicate, right? That they might be able to use their neural activity to pick out letters or words on a screen, right? If they have difficulty communicating verbally. And one of the things, we heard lots of interesting things, but one of the things we heard was about concerns about privacy. You know, some people had found the idea that that researchers or clinicians might be able to record their brain activity sort of scary. And then others sort of felt like, this is a perfectly fine trade-off, right? If it allows me to communicate and continue to communicate, despite the progression of my illness, it's a trade-off that I gladly make. So it just sort of characterized for us sort of the complexity of the issue of privacy, which is something that I think we're all sort of struggling with in lots of areas of our lives right now. And finally, the last topic I wanted to talk about was kind of return to what the project that Dr. Song had described, which is around the issue of cognitive enhancement. And right, so I mean, this is a topic that this kinds of research on memory is going to raise, right? So it's going to raise questions about what is cognitive enhancement, or what counts as cognitive enhancement, what counts as treatment, right? How should it be studied? Are there limits to this kinds of research? And as was raised in the question, who should have access to this, and how do we ensure that it's the access is equitable? All right, so I'm gonna finish there. I just the point of sort of these quotes isn't to say that these are the views of all end users or potential end users, or that these views are universally shared, or that they ought to dictate kind of what happens with research. But it's just to point out that it's these kinds of data points that haven't traditionally been part of technology development, and yet they seem particularly relevant to have not just to at least have on the table, right? For engineering teams, for clinicians, for funders, for companies, for science policymakers, as they make choices about kind of technology and how it gets developed. So so I just want to thank the many people that I get to work with, including Professors Illes and Song and Garrett.
All right, thank you, Dr. Klein. So some questions rolling in from the Discord. We have Ashley M again. So more of a philosophical than a scientific question, but if neurotechnology had somehow been developed centuries in the past, do you think that they would have a different outlook on whether it was ethical to use?
Yeah, so that's a really interesting question. I'm not sure how to answer that. I mean, I guess it's similar to asking the question, will we in the future, if this technology is successful, will we think about these ethical questions differently? And I'm sure that in some ways, yes. I think I think we all get shaped, and society gets shaped by what technologies become commonplace and accepted. And but I suspect that it'll raise new capabilities of these technologies, will raise new questions. So
great. We have another question from Eli Kinney Lang, who says, user-centered design is a critical consideration and important when considering new neurotechnology development. How do you better incorporate underrepresented communities like pediatrics into this conversation? Well, so I mean, I think you give priority to recruiting into the recruiting voices of underrepresented communities. So and that means, so when we go out and we talk to individuals about these technologies, whether they're current technologies or future technologies, we really try to get a diverse sample of individuals, because the whole point of doing this is to get all kinds of ideas and perspectives on the table. And if we're leaving particular groups out, then we're missing out on something really important. Okay. And then one last question from Oscar Petrov. So how do we decide what is generally experimentally ethical with regards to various groups and nations if they're pursuing different methodologies? So how do we sort of generalize ethics across groups?
Yeah, so I think this is a topic that philosophical ethics struggles with, just sort of generally, right? That how do you are there different ethical standards across different cultures? And I don't have an easy answer to that, other than to say that that I think the important thing is to put those cultures, those different ideologies sometimes in conversation with each other. And I think the kind of more we're in conversation with each other, I think the more we find that there are common principles, common values. So I think we're often not as far apart as sometimes we assume that we are.
Great. All right. So thank you for your presentation. And finally, I'd like to introduce Dr. Judy Illes and her talk in the Vortex of Signals from Brain Wearables. Dr. Illes is a past president of the International Neuroethics Society and director of Neuroethics Canada at the University of British Columbia. A pioneer and eminent scholar in the field of neuroethics, she has made groundbreaking contributions to ethical, social, and policy challenges at the intersection of biomedical ethics and neuroscience, emerging neurotechnologies for neurologic and psychiatric conditions, decision-making, cultural values, and the commercialization of healthcare. Thank you, Dr. Illes.
Garrett, thanks so much for that nice introduction. Let me just get my screen shared for all of you. Dr. Song and Dr. Klein, amazing presentations. Thank you. And amazing questions from the audience so far. Just to check, can you see my slides all right? All right, yes. Very good. I would like to begin by acknowledging my team at Neuroethics Canada, many of whom are with us on Livewire today as part of Voices and Visions of this wonderful USC event. I also want to acknowledge all of those who support us, especially the projects that I'll be talking about today. And I want to acknowledge that I'm joining you from British Columbia, and I'm working and so privileged to speak with you today from the lands of the Squamish-Lillooet First Nations people, the Musqueam First Nations, and the Tsleil-Waututh First Nations people here in British Columbia. I have no disclosures, and that's an important comment to make, particularly as we enter a different kind of space from the one that Dr. Song and Dr. Klein were talking about, which is the commercial space of wearable, non-invasive technologies, and we focus on the brain. So I'm going to try to advance my screen. I'm going to ask the audience 2 questions. If we were in a giant auditorium, I'd actually be able to see you and see your answers. I hope I don't crash Zoom by asking you these questions, but we're going to give it a whirl. We're going to give it a try. How many of you, of the 180 people on Zoom with us this afternoon, own some kind of body sensor, a Fitbit, a heart monitor, and you can use any kind of emoji in the reactions tool to answer the question? Okay, we have some answers still coming in. Okay, I won't take too long. Keep it coming though. I obviously have no idea how many of you are actually saying yes, but I'm going to predict that it's 80% of the group who's with us this afternoon. Now, I'm going to ask in a second question is how many of you own a brain sensor? So take your hands away from the body sensor, and how many of you actually own a brain sensor? And I know that this is not going to be a representative group because probably many of you do, because this is a neurotechnology interested group. All right, I see answers still coming, but I'm going to move on, but you can keep answering. I'm going to suggest that about 10 to 20% of you, so maybe 30 to 40 people of this audience actually own some kind of brain sensor. And I'm also going to suggest to you that that number is going to increase by about 10% each year over the next 5 years, a little bit mapping the neuroprosthesis landscape that Dr. Song showed us in his slide earlier. So the landscape of opportunity for these devices is immense. They're immense in the direct-to-consumer space, and they're valued today to be at about $34 billion US. That's somewhere around 45 billion Canadian dollars, or depending on the exchange rate. And my team and I were very interested in 2009 to understand what this industry really looks like. So we turned to the publicly available open access websites of 41 device companies to study what they were selling, developing, innovating, and promoting to consumers like you and me. Of the 41 device websites, we found that half were stimulating devices and half were recording devices, all using electrical currents of one form or another, either input or output devices to put in signals into the brain or take signals out. 2 of the 41 companies that we found were actually both recording and stimulating device companies. Who were the users? The users were people like mostly you. I will predict people in the 20 to 35 or 40-year-old age range, mostly athletes and trainers, and secondarily employers and employees. But otherwise, there was a wide range of users targeted by these technologies, including researchers for using devices for research, religious leaders for trying to understand the physiological basis of the spirit, and even occasionally a device that was marketed to your pet. And you can make some decisions about the value of that offline, or we can have a discussion about it. What were the claims of benefit? We found 166 unique claims of benefit across the 41 devices. Mostly they were marketed in claims of wellness products. And you'll recall that both in Canada and the United States, health products require regulatory approval. Wellness products fall under that radar. So most of these, almost all of them, in fact, were marketed as wellness products, some to relieve stress and anxiety, some to improve memory and sleep, and almost all making claims about controlling the mind through neurofeedback. Now, as scientists and engineers and ethicists, we're always interested in the evidence that underlies claims of benefit, and we studied those as well. And we found that almost all of the device websites had some sort of evidence on its website, again, on the publicly available sites, but actually only 20% of the overall claims of evidence were actually relevant. Some were, and relevance taken writ large. So many were testimonies from outside users, from consumers. Some were evidence of rhetorical content. So that would be, for example, somebody from within the company promoting the benefits of the company's claims. And even we found some irrelevant and broken links provided as evidence to support the claims that the companies were putting forward. What were some of the risks? Well, we found some claims of safety, but not a lot. And so safety would be in this context of wearable neurotechnology, skin irritation, for example. But we found nothing about the intermixing of conventional therapeutics, for example, like psychological support or counseling, with these kinds of new technological innovations. And if you loop back to what I presented to you about the main claims of these devices, stress and anxiety, improving memory, improving speed of information processing, improving sleep, those really cross the fine line of health and health-related conditions. And yet we saw no evidence of risks that encouraged individuals to be cautious, to not move away from conventional therapeutics, especially those that were beneficial, favoring the use and the purchase of these novel kinds of neurotechnological devices. What about incidental findings? Well, what are those? Those are surprises. Surprises on your recordings that aren't expected because they look abnormal or maybe abnormal, or they might be surprises in terms of a behavior that a stimulating device actually causes. In another study that we conducted in the same year as our website device study, we conducted interviews with CEOs and representatives, high-level representatives from neurotechnology companies. And we learned from them that to date, there's no formal strategy for handling incidental findings among these neurotechnology groups. Many of them don't actually collect data that could be used to process incidental findings. And many of them claimed that the kinds of recordings they were receiving would not allow for an incidental finding to be detected. Nonetheless, they indicated to us that it wasn't a bad idea to be thinking about these things. They do offer customer service for product complaints and adverse events. And so our study, we learned, generated among them both thinking on the topic about incidental findings, and I must say some heated controversy that we learned about as well. So let's move on to yet a third study, and this is a study that we have going on at Neuroethics Canada right now. You can find the link to the study on Twitter and on my website. We actually have been asking employers and employees about their use, whether it's required or self-directed, their use about wearable technology, again, both on the body and on the brain. And so these are hot off the press data. We have found that both sides agree on three major points. And they are that if there are medically relevant incidental findings from recordings from employees, the employer has the obligation to report it out to the employee. We learned from both sides, and this surprised us a little bit, that employers and employees believe that the employee owns his and her brain data. And finally, we learned from both employees and employers that data from an employee, brain data, brain signals from an employee should not follow the employee from workplace to workplace, but reside in the workplace and with the person in which it was obtained. So I'm going to wrap up here. I'm going to suggest to you that the lines are too blurry today between the recreational device space, which is these neuro wearables and body sensors that you can buy in Best Buy and other big box stores. There's too much of a blurry line between these wellness products and what in fact ride the fine line of medical devices or health products. I think our neurotechnology sector needs to do better, especially when it comes to the brain. The neurotechnology sector needs to be more transparent and actually put protection of people and brains above profit. We'd like to see, through a number of organizations, we've recommended that neurotechnology industry self-govern better than it's been governing before. And it's really a way of ensuring that external regulations don't come booming down in ways that are sometimes punitive, sometimes irrelevant, and always, always very slow to change. Finally, I'd like to suggest that a harmonization of ethical protections and ethical values across neurotechnology industry, across the international community, would be invaluable in pushing and promoting the benefits of this kind of technology forward. And at the end of the day, there's really an algorithmic growth in the capacity enabled by pattern recognition to read brain signals, to place brain signals into the brain, and users need to be well informed about the choices that they're making and make good choices, both for today and for tomorrow. And with that, I'll conclude and invite your questions.
All right, thank you, Dr. Illes. We have one quick one from Joe Artuso. Where can we find the survey results that you're discussing? Are they published?
The survey results from the website study, so the content analysis is available in a publication in Neuron. The first author will be Minieli. As the results of the incidental findings study, the interview study was published in a chapter on actually, and that this audience might be interested in it, in a series that I edit called Developments in Neuroethics and Bioethics. And the volume specifically is on do-it-yourself technology, edited by Imre Bart and Elizabeth Hilt. And the study from the survey study that's ongoing now is not published yet because we want you all to respond to it and give us your views. And so of course that publication is forthcoming in the near future. Thanks for the question.
We have one more, which is, how can we ensure the public has enough information about BCIs before receiving them? Is there a way that we can properly inform the public?
Well, you know, that's a great question. And it's on all of us. It's on the innovators, the engineers and scientists in the innovation sector to be transparent. It's on the people who develop the marketing strategies to be transparent and more forthright. and less obtuse than they've been. I think it's on science journalists to communicate well about what's going on in the innovation sector. And there's a lot on us as neuroethicists to help all of these stakeholders do their job well so that the public can really trust what's out there and, again, make really good choices.
Awesome. So thank you again for your talk, and thank you to all the speakers for their wonderful presentations. So now it's time to get slightly more speculative. Over the past year, the Brains at Play initiative has been developing a software library for developing brain-controlled websites and unveiled Brainstorm, a multiplayer game that couples minds across geographic, social, and cultural boundaries. We've grown a lot since our early days at the USC Amundsen Lab and the USC Sydney Harman Academy for Polymathic Study. And in truth, the Brainstorm has only just begun. All right, and now that we've heard from our first round of speakers and gotten a taste of what's to come, it's time for you to brainstorm with us about the future of neurotechnology. As mentioned earlier, this portion of the event is highly participatory and takes place on the Brains at Play Discord server. In addition to text channels for each of our invited experts, we've also opened a voice channel called BCI Livestream, where some of the student team featured in the video just shown will be playing brain-controlled games on the Brains at Play website. While I'll be staying behind and inviting our experts to publicly comment on high engagement posts here on Zoom, we encourage you to engage fully in the Discord at this time if it's possible, to share your perspective and opinions on neurotechnology, and take full advantage of the amazing minds we have here for you today. So it looks like we have about 15 minutes, and let's get started. So I will invite Dr. Song back up and have him comment on a question from Alec that was previously unanswered during the Q&A. So Alec asks, was the hippocampal model trained for each individual? And if so, how would we design a prosthesis for a patient with an already damaged hippocampus?
Yeah, that's a great question. And I got this question almost every time from some smart audience. So for now, what we build, as Alex correctly pointed out, are all patient-specific model. So we record data from each patient and build by mathematical model using data from that patient, and use that model to enhance the memory function for that specific patient. So as I said, there's still a long way to go to move from here to eventually build the hippocampal memory prosthesis for helping people with brain damage, right? But there are several possible solutions for this problem. First is we can try to build sort of generic model that can work for different patients. We identify the similarity or the differences across different patients in terms of the signal transmission. So we can build a patient general model that can be used from one patient to another patient. And second is we may rely on neuroplasticity, which exists in all brain regions, right? We provide the signal as best as we can, and hope that the downstream brain region can be smart enough or plastic enough to differentiate the signals and to better use those signals for the memory formation. And obviously, all those approaches need to be tested in future human studies.
Wonderful. So now I'd like to jump over to Tim Brown. Tim is a postdoc in Eran's lab, and Caitlin Ringrose asked him, how do you garner end user perspectives to ensure that you're getting a diverse array of experiences in your studies?
Hi, everybody. So the answer to this question is that you have to acknowledge the problem, and then you have to go and take active steps to remedying it, right? So you can't just go, okay, so we are limited by where we are, or by the kinds of people that are in our labs, or by our inability to reach out to new groups, right? There's too much at stake, right? Our science could be wrong as a result of our inability to get a diverse set of perspectives. So we have to reach out to groups in other areas. And in our group, we've done that through our work with you, Garrett and Dong, reaching out to, well, it's not a secret that Seattle's a pretty white place. And so any kinds of end user interviews like the ones that we do are gonna, favor white men usually. And so reaching out to communities, reaching out to different research groups, reaching out in general is extremely important, and not being afraid to do that kind of outreach work. But also thinking of it structurally, we can also think of ourselves as situated in institutions that stand against us, that make it hard to diversify our research in general. So acknowledging that and trying to work to dismantle the systems of oppression within our institutions, even though that seems like an insurmountable task, if we come together, we can do it. Yeah. Does that get at the answer the question a little bit? Maybe not.
Yeah, thank you, Tim. I appreciate it.
Maybe not a satisfying answer, but it's something we need to do.
Awesome. Now I'd like to invite Jeremy Greenberg and Caitlin Ringrose up to jointly discuss the question by Ashley M. If we can barely trust companies to handle data that we willingly put out in the world, how can we trust them with data from our own minds?
I'll let Jeremy go first.
Yeah, I mean, that's a big question there. There's, in terms of legislation in this area, it seems like that's the way to go. If we want private companies, if we want this data to be used responsibly. And I think that there are a couple different options here. You have a number of comprehensive privacy bills and laws being passed globally, also in the States here in the US and California, and most recently Virginia. And perhaps this is part of a comprehensive privacy law. We call out neurodata or this technology specifically. Maybe it warrants higher protections given its sensitivity, or perhaps it deserves its own specific legislation. I think that there are a couple ways to go here, but I really do think it's going to be through regulation.
Yeah, I think it's hard, right? If we can't trust companies, how can we trust policymakers? Laws move incredibly slowly. Like Jeremy mentioned, there's some state privacy laws now that may or may not include biometric data, which might include neuro data. But if you just have a few states with comprehensive privacy laws, that's not good enough. And then what's to say that the laws will include neuro data? And what's to say that the laws are even helpful in the first place? So there's a lot of questions there right now. And if we can't, trust one another, what can we do? We can put forward self-regulatory models. We can ensure that we have ethical principles. And I know I want to give a shout out here quickly too. IEEE Brain has been working on some ethical, legal, and social principles for developers of neurotechnologies. And I'll say that that's a great first step. But we all need to kind of move in concert, educate one another. Policymakers, it's difficult. They all have jobs and other bills that they have to pass. They're not going to be able to understand neurotech. Jeremy and I are lawyers. We don't understand neurotech. We try. So the most we can all do is educate one another and, keep holding one another accountable as we move forward in the space.
Yeah, and just to echo, I think that there are, a lot of conversations that need to happen about this specific data. When you're talking about someone's thought patterns, it seems like there's an extra layer of sensitivity that we have not encountered. This is not typical biometric data. So I think, yeah, these conversations need to happen and be debated and, yeah, introduced to policymakers and lawmakers.
Awesome. Thank you both for those responses. Now that we've discussed a little bit about the public side of brain-computer interfaces, I'd like to invite James Giordano up to sort of address the question of what is dual use in BCIs and how can BCIs be used in sort of that sort of sense.
Thanks very much. And a real shout out to Caitlin also for mentioning some of our ongoing work at IEEE. I have the privilege and honor of now being chair emeritus of the neuroethics section of the IEEE Brain Initiative. And my colleague's point on that was accurate. And I really want to applaud Professor Illes' very, very astute comment about the OECD, the Organization for Economic Cooperation and Development, trying to get international discourse on this or even trying to stimulate dialectic where you have one position, another position, you're trying to get something synthetic. It's very easy to talk about. I mean, our conversation here is but an hour long. It's not so easy to do. And you have different perspectives with different cultures and different values. And this also speaks very strongly to the issue of dual use. Realistically, if we look at any neuroscience or technology, I think that the guiding aim is to try to advance the science and tech for good. Now, the big question there is not only philosophical, it's very practical. Who's good? What rationality? What aims? I mean, realistically, even if we're considering dual use, where dual use would be more specifically regarded for things that might have some interest in national intelligence, security, and defense, even national intelligence and security is aimed at trying to keep the polis secure, at least in an open society, a democratic society. Here, the issue is that the military serves the body politic, and the politic then is trying to protect the polis. So the issue here is what's good for kin, what's good for kith, and how do we keep that safe and sound? But once we begin to get into international discourses, have to recognize that, as my colleagues have very well alluded to, there's a lot of economic power that goes along with neuroscience and technology, not to mention what Michel Foucault, the philosopher, referred to as biopower, being able to affect individuals on a biological level to then affect in some way the way they think, the way they feel, and the way they're acting. And this is real. This isn't science fiction. I mean, we take a look at some of the work of Elon Musk, we take a look at some of the work of very avant-gardistic DARPA programs, not only that are occurring here in the United States, but a number of DARPA-mimetic, DARPA-like programs that are occurring worldwide. I had the opportunity to serve, for example, with the European Union's Human Brain Project on dual use, and it became very apparent that the need to understand what's going on the commercial sector, on the governmental sector, on the research and academic sector, is very often fueled by various nations' triple helix, the union of government, research, and the commercial enterprise to advance, on one level, neuroscience and technology for economic gain, which certainly affects international hegemonies, leveraging power, but also on the military side and on the intelligence side. And here we're not necessarily talking about weapons of mass destruction, but rather instruments of mass disruption on a variety of scales and levels that range from the cellular all the way to the social, from the individual to the international. And we need only take a look at the recently published National Academy's report with regard to the way directed energy devices are being utilized to affect patterns of neurological activity to therefore evoke effects on cognition, emotion, and behavior in key targeted individuals, to recognize that we now have the capability to engage, develop, and utilize tools of precision pathology. That's frightening, it should be, because the level of discourse on the international level is nascent. Current international signatory treaties, such as the Biological Toxins and Weapons Conventions and Chemical Weapons Conventions, are just now beginning to scratch the surface of what neurotechnology can do and how neurotechnology, in fact, should be viewed, guided, and governed. And the question is, if in fact that governance is in place, what are going to be the necessary safeguards to oversee that, and who decides? So these are key questions. And I think in the spirit of the philosopher of science, Bruno Latour, what good science does is not only answer questions, it generates others, but not only in the scientific field, certainly in the ethical field, in the social field, in the policy field, and more that needs to be leveraged on an international, multidisciplinary, and global stage. So I think that the questions here are really whether the extant ethical principles are adequate, and if they are in fact sufficient. And the answer that has come back to my colleagues in working in a variety of different forums, inclusive of NATO, World Health Organization, UNESCO, has been no. These current principles are not enough. Some of my prior work with Professor Illes and her colleagues up at UBC have recognized the need for an international neuroethics. Once again, easy to say, not terribly easy to do. It's a discursive process, but more than that, it requires dialectic, and that dialectic requires a reflective equilibrium, and you have to be aware of different definitions of the good and the strivings that it's going to take at those discussion tables and in the reality of pragmatic neuroscience in the public and in the political spheres to define those goods, compromise on some levels, and some levels of consensus. Not easy. It's going to require work. And at the end of the day, I think that we can all decide that that juice is proverbially worth the squeeze, so to speak, because we are our brains. And increasingly what we're seeing is the brain is going to become at least a partial battlescape of the 21st century, not necessarily in terms of bullets and bombs, but of influence, impact, dissuasion. And that's important to consider, because every sword has two sides, one that may be relegated to heal and one that may be relegated to harm. And those harms are very often disguised as goods and what those different values are for various cultures, various politics, and various aims. Over to you.
Thank you, Dr. Giordano. I'd like to bring up one final speaker. Laura Cabrera was asked sort of, how do we define invasiveness in just general neurotechnology as well as sort of in neuroethics? What are the different perspectives that we can bring upon that label?
Hi, Garrett. Hi, everyone. I mean, that's a very interesting question, and it was great that it was brought by one of the, people in the forum, where they say, that EEG can be not seen as invasive from a physical perspective, but it can be seen as invasive from a more social perspective. And it's really interesting because in a recent project where we saw looking at different interventions from TMS, DBS, electroconvulsive therapy, that people do have different perceptions regarding invasiveness. So they don't only consider physical invasiveness as something that we should worry from an ethical point of view, but we should also consider things like, are these technologies being invasive from a lifestyle perspective? For example, the use of, in this case was for therapeutic uses, that TMS for depression, you have to go several times in a week to get your treatment. So that was seen as invasive from the patient's perspectives. Or in the case of when we talk about how would you compare invasiveness of ECT versus, going to psychotherapy, they do so psychotherapy as more invasive from an emotional perspective. There were also participants that say, well, going through DBS is invasive emotionally, like I feel really, emotionally invested in using this type of invasive technology. So I think we should really try to start unpacking what invasiveness really means and the different kind of layers that come when we discuss invasiveness beyond just the physical.
Awesome, thank you for that response. And With that, I think we will conclude the public brainstorm. If you all want to continue asking questions on Discord, I encourage you to do so. But for now, to conclude our time together, I'd like to introduce Joe Artuso. Joe is the Director of Marketing and Business Development at OpenBCI, which provided some of the brain sensing headbands featured in the Brains at Play demo video today and in the BCI livestream channel. Joe will conclude Livewire with a presentation entitled Democratization, DRM, and Descartes, the Case for Open Neurotech. Thanks for being here, Joe.
Thanks a lot, Garrett. Just gonna make sure I can get my slides set up the right way. All right, you seeing it clearly? Great.
Yes.
Yeah. So thanks again for having me. It's really a pleasure to be a part of this event and be here with so many other talented people. You'll notice that I'm the Director of Marketing and Business Development. I'm not a neuroscientist or an ethicist, but I did spend several years working in the ad tech industry before joining up with OpenBCI, and I think that neurotech has a lot to learn from some of the ethical failings that happened there. One of the most common questions that I get asked at OpenBCI is like, why are you open source? Actually, it's usually one of the first things, and then people start asking how the hardware actually works. But to answer this question, I want to touch on kind of three different ideas from a couple of thinkers. Some ideas from Linus Torvalds, the creator of Linux and an early open source pioneer. Cory Doctorow, author and activist and technologist, who discussed at length kind of the copyright wars and digital rights management, and then also sort of discuss how Rene Descartes' famous thought experiment that led him to I think therefore I am, and the doubt and skepticism that he brought to philosophy takes on an entirely new color in a BCI powered world. So starting it off with democratization, there's this sort of saying called Linus's law, which is that given enough eyeballs, all bugs are shallow. And this actually came from a book called The Cathedral and the Bazaar by Eric S. Raymond. And it's kind of this collection of lessons on software development from open source's early days. And it's a paraphrasing of lesson 8, which is given a large enough beta tester and co-developer base, almost every problem will be characterized quickly and the fix obvious to someone. The takeaway from this is that opening your code to a large audience actually builds better tools. And it's something that we've taken to heart at OpenBCI and gotten a lot of benefit out of by creating technology that's open and transparent by design. We actually, we want people to be able to see and replicate the way it works so that they can show us where it's not working. We believe that process, and adopting openness and transparency from the get-go is really going to create better tools in the long run. You don't need to just take my word for it, though. You can see that there's been an open source renaissance in the business world with huge merger and acquisition activity among open source companies in the last several years. So I think that there's a growing body of proof that shows this approach to development can produce better tools, and it's something that neurotech can learn from. But there's not just a business benefit to this. One of the other reasons why I think that neurotech development needs to be happening out in the open in a way where people can interact with it, in a way where people can learn from other findings or build off of other people's products, is because what's the alternative? The alternative is that a small group of companies or well-funded organizations are developing the standards, are furthering the technology, and really the only ones that understand how it works. One of the things that we think about at OpenBCI a lot is kind of this idea of raising the floor that other people start at in the industry. And we're trying to promote that, and we think that the industry as a whole could learn a lot from, just taking that approach of, will this tool make it easier for somebody else to get started after me? There's also this concept of BCI literacy that I like to reference. And for any functioning society, having an educated population is important to it functioning well. And the same thing applies to the neurotech space. We need to maximize the number of people that have accessible and transparent tools so that they can become literate in the functionings of this technology as it enters, the mainstream. It's because these BCI literate people will be the ones that that are checking for false claims, that are making sure people aren't being manipulated. And without them, there is no informed public that can keep some of the worst actors in check. So I think, by making neurotech open by design, we can create better tools, create that kind of BCI literate public, and hedge against bad actors. And as a demonstration of this, I think there's a lot that we can learn from the war on copyright and the war on general purpose computing and things that happened in the early 2000s around digital rights management. It all sort of started with the DMCA. There was an act passed in 1998, and some of you may notice, that this screenshot from movies and DVDs at the time, for anti-piracy PSA. But the dawn of computers and the internet really changed the game for copyright law. And there was this scrambling of technological and legislative measures to try and control what could and couldn't be done in this new technology space. And it feels a lot like where we are today with neurotech. Cory Doctorow gave a couple of talks on this. That I want to paraphrase here. But I mention them down in the corner there, and you should go have a listen to them. But computers are everywhere, and increasingly they're in our bodies. He references pacemakers and hearing aids, but today he would be talking about Neuralink. The future will, because of this, the future is going to be full of socio-political problems about governing the use of computers, and sort of he blanket refers to that as like digital rights management. Restricting computers to only approved functions often relies on techniques that obscure or limit user control. And these techniques generally lead to weaker overall security and have been the root of a number of hacks. The root of the problem here that we're looking at with neurotech now is that there's a number of great reasons to say, make me a computer that runs all the programs except for the one that freaks me out. Make me a BCI that allows me to cure Alzheimer's, but doesn't allow my thoughts to be manipulated by companies trying to advertise to me. So there's always a great reason to want to prohibit a certain action. But once you start going down this road, you get into the very difficult question that many other speakers have touched on today: is who decides what can and can't be done in these situations, and especially with computers that we start to interface with our bodies. I think generally the answer, comes down to one of these four groups today, at least. And I think in our current world, the manufacturers are actually really at the top of the food chain, and they're going back and forth with government about, what can and can't be done. You can kind of see this. Facebook and Apple are fighting over what is and isn't allowed to be collected from iOS, which would jeopardize Facebook's advertising business. This is a microcosm of a dispute that could happen in the future with some sort of implantable neurotechnology device. I think that openness by design and giving users the ability to understand what is happening inside their devices, what functionality is being controlled or prohibited or limited by the other actors on this table, is a very important part of bringing some much needed power back to device users. The reason is that these efforts to control what can and can't be done with computers often have unintended consequences. And I could cherry pick headlines for over the last several decades, not too hard to find. One of the most interesting ones was, even just last December, there was this huge hack called SolarWinds, an IT product that was designed to manage devices for company and government organizations, was compromised, led to this huge breach that's still being unraveled by security researchers. And what's especially interesting about that, I think, was Microsoft's response to this hack was kind of like no big deal to them. At least their public response was that open source software development best practices inside of Microsoft mean that they're no longer relying on kind of the secrecy of their source code, the secrecy of the inner working of their devices as a measure of security. It doesn't, having access to the source code is no longer an elevation of risk for them. And this is another sort of example of how, by creating tools that are open by design from the get-go, you can mitigate some of the risks of, what would not have been a foreseeable, threat to them when they were designing these operating systems in the first place. And back to a quote from Cory Doctorow that I really like. This was 10 years ago, and it still holds true to me today is freedom in the future will require us to have the capacity to monitor our devices and set meaningful policy on them, to examine and terminate the processes that run on them, to maintain them as honest servants to our will and not as traitors and spies working for criminals, thugs, and control freaks. The alternative to open neurotech is kind of black box and proprietary systems that are only going to make it more difficult to validate functionality, detect security flaws, and protect users from manipulation. I do truly believe in the kind of Linus's law effect of getting as many eyeballs on things as possible helps to suss out the problems. But this idea of manipulation from BCIs also, I think, takes on a whole new flavor for Descartes' thought experiment, where he really, he started off with this imagining of a demon or an entity that was all powerful and manipulating his senses. And from that sort of complete doubt, he actually proceeded to build a single kernel of truth in, his own existence, because he was a thinking being. And from that one kernel of truth, he then extended out to build an entire sort of school of philosophical thought around it. And arriving at that single kernel of truth is going to become more and more difficult as the capabilities of Descartes' demon are actually entering, technical, the realm of technical possibility. It's feasible that our hearing and our senses are going to be able to be altered by devices that we implant in our body. So the idea that you'll be able to, the idea that you're going to be able to build up to some sort of kernel of truth is going to require that you have transparency into how these devices are working. It's going to require that the more open these devices are, the more transparent they are in their workings, the easier it's going to be for you to sort of, and for security researchers and for the educated BCI public to validate that this is working the way it's intended. There isn't any secret bugs or hidden, gotchas baked into this thing. And it's going to be essential for us, arriving at certainty in a post-BCI world. So to summarize, I think that by building tools that are open by design, we can maximize the number of BCI literate users and actually, build better tools and a better population in the first place. We can protect users from the dangers of even well-intentioned digital rights management, and we can help us arrive at certainty, by protecting from false claims and manipulation. So thank you so much. I'll be around in the Discord afterwards if you'd like to talk. And Garrett, thanks a lot for having me.
Awesome. Thank you, Joe. And I did want to actually highlight a question by Juliana about advertising, sort of spanning both of your history and your present. So do you think advertising for neurotech should be regulated, and also if it should, like how? I thought you gave a very interesting answer on the Discord. So
yeah, I can I'll resurface it here. I do think, I think it's great that the US government is sort of rediscovering some regulatory muscle and taking action against major tech companies. I think that one of the best ways to regulate advertising is to focus on the platforms that are delivering the advertisements, on behalf of advertisers, the places where the ads are actually being like loaded up and sort of scheduled and arranged. This is I don't know, mostly this is Google and Facebook. By making them responsible for manipulative or sort of bad faith advertising that's happening, it'll get taken care of pretty quickly, technically. They'll find ways to make sure that they're not getting penalized for bad actors on their platforms if you hold them responsible.
Awesome. Thank you for that. And with that, I'd like to thank Joe for a great talk and everyone in the audience for spending your evening with us. This concludes the formal portion of Livewire's Stimulating Night of Neurotechnology. If you have more questions or would simply like to keep interacting with our event experts and attendees, feel free to linger here on Zoom or on Discord. We'll start breaking everybody out into breakout rooms if you would like to ask more pointed questions to each of the discussion facilitators and speakers, as long as they themselves can stay here for that time. In general, I'd like to thank USC Visions and Voices, Mirantina Gotsis, Curtis Fletcher, all of tonight's speakers and invited experts, and the Brains at Play student team for the work they've put into Livewire over the past year. It really wouldn't have been possible without such an amazing team, and I'm very grateful for everybody's support along the way. If you'd like more from the Brains at Play initiative, we have an international design fiction competition going on right now until March 10th. So if you have an idea for a brain-controlled game, consider submitting and have the chance to win a Muse2 headband or Open BCI ganglion to play these games with, as well as potentially $5,000 from the USC Smart VR Center. Again, we hope you had a wonderful time here. We will open up breakout rooms momentarily, and we look forward to hearing your questions and continuing your engagement with us.